Hello, welcome back to my shop. Today we're going to work on a piece of vintage equipment. This is a Heathkit V-7 vacuum tube voltmeter. These were pretty much the standard back in their days. They were very nice meter with a input impedance of infinity pretty much. And they did a great job. I got this a long time ago, and I know it works sort of. The guy told me that the AC doesn't work right, but we'll find out. We're gonna plug it in. I know I can plug it in. It's never blown up on me before. As you can see, one of the knobs is gone here. If we turn it on, you have to wait for these. They're vacuum tubes, remember? If we turn it on, there it goes. Vacuum tube, light up, peg it the other way, and eventually it'll come off the peg there. Maybe. Oh, there we go. Okay. You have to zero them out. And you really should wait for them to go for a while, because they're vacuum tubes. Yes, tubes, valves as they call them. I did not get a probe with this, so I ended up with making one. It's an old scope probe, and I took all the guts out of it. We'll see what this did. Oh, that's the DC volts anyway. Well, let's test it all out here. Yeah, see? You have to adjust it down to 0. There we go. And the ground is not connected to ground through this probe, so you have to use a separate ground on these, which is over here. And let's see if we can get some measurements here. All right, let's see if we get any voltage on this thing. We've got the power supply turned on, and let's take it up to 12 volts. Close enough. And we'll hook up the negative to the negative. Put this thing on DC. 15 volts DC. Wow, that's AC. I want DC plus. Okay, there we go. Adjust it to 0 and attach. What do we got? Wow, on the 15 volt scale, it's right dead on 12 volts. That's that's pretty good. There, take a look. Oh, it's a little bit over, but I haven't let the tubes warm up for half an hour or more. So the DC works, we know that. Let's try ohms. Unplug that one. Yes, you have to change things here. Get the other probe. Switch her over to the ohm scale. Now on these old ones like this, you had to adjust the ohms for 0, well, infinity, because if the probes are open, it's not, you know, they're not nothing there. Wrong probe. So that would be definitely infinity. And you plug them in here and short them together, and you'll have 0. Sure enough. Wow, okay, that works. How accurate is it? I don't know. Let's find a resistor. These new resistors are harder than heck to read. I don't really know. But we'll try it. We'll see what this does. Okay, too high. Okay, so this thing says that it is, wow, 1.5 ohms. That's a 0 ohm resistor, or is this thing just, well, I have a feeling that this is a short, just this resistor is just a short. Okay, let's get one here and try it out. Let's go for a 1K. Got lots of those. But at least we know that the thing actually does read something. Okay, here's a 1K resistor. Nothing, of course. Let's put it on the R times 100, so. And what do we got? 10. Well, how you like that? That's pretty accurate. It's a 1K resistor and we've got 1K. Let's put it up a different scale here. See how it does. Okay, that's good. Let's test this on a known good ohm meter. 1.007. Okay, that's good. We know it works on ohms. We know it works on DC. So let's turn on the function generator. Turn off the power supply. Don't need that for now. And get a little meter here. Test lead. Okay. And let's put it on AC. Okay, it's zeroed itself pretty well. Okay, we'll set this guy for 1 times 1K, 1000 hertz, and sine wave, and we'll hook it up to it. Turn the output down some. Alright. And we'll take this down because I don't think this thing's got much out, and I know it doesn't have much output voltage. We'll crank it up here, see what we've got. According to this, on the 5-volt scale, we have about 2.3, 2.4, going up a little bit, wavering around just a little bit too. And when I touch things, okay. What do we actually have? Let's take our known good meter and take a look at it. Negative and positive. We have approximately 10 volts. And we're on the 5-volt scale. Don't let that top one fool you. We're on the 5-volt scale, which is right there. That's saying about 2.4 volts. Okay, that ain't right. So we'll have to yes, it's wrong. Okay, so we have an actual repair to do. Let's unplug it. Okay, take the leads out of it. Let's find out what we've got going on. Coffee first. Alright, so let's take this thing apart. Busted knob. Yeah, it works. It's good enough. So it appears the only thing holding this together is a couple of screws, which we'll take out. And yeah, it appears. And yep, that's it. All right, there we go. Okay, I see something interesting already. What is that? We appear to have an add-on board. What's on there? There's a little resistor. Yeah, you can see that. That board has a. Okay, well, this thing's supposed to have a battery in it for the. There's a battery that's supposed to go in there for the ohms range, and it doesn't have a battery, but the ohms were working. I'll bet you that's a voltage regulator for 1.5 volts to replace the D cell that was supposed to go in there. Huh. Well, that's cute. We know it works because it worked. Cheaper than batteries, I guess. Okay, well, let's continue taking this thing apart. All right, so we do have a manual for this. Well, I got a schematic for this, and it's, if I trace it out, we know that everything on here works except for the AC. So if we look at this, we've got this particular schematic is shown in AC mode. So the AC comes in here, and well, let's see here, AC comes along this line, comes up to this wiper on that switch, goes out this wiper on this switch, down through all this stuff. Okay, but the contact there, right there it is, goes down here, across, up to a 1500 volt 0.01 capacitor for dropping, so passes AC, no DC, and all of the ranges except for the really high range here, the two high ranges are connected together, and they go through this 0.02, another capacitor, okay, through that 0.02 to the 6A05 dual diode, that's a tube, right there, and through a 22 mega ohm resistor. Wow, okay. To a whole ladder of 22 mega ohm resistors, and also down to the front of this switch, which goes down to the range switch here. Alright, so we're just selecting the range that we want for the AC here. We are selecting the output. It goes over to that there, the AC balance, and that has a 100 ohm resistor and 27K over to the 0 adjustment. Alright, so we've got one heck of a ladder. 22, 44, 66, 88, 102, 88, 98, 108, 110 mega ohms. Series resistance over to the AC balance, and then 27K over to here to this 10K. Alright, well, that means that something along the lines has to be bad. Now what? Well, we're going to guess. We got to check a couple of capacitors here. And the capacitors we want to check are right in here, I think. Let's find out. That is the 6AL5 tube right there. And the two capacitors, that'd be those guys right there. That's the .02s. And then the big capacitor that everything goes through is right down here. Let's see. The AC comes in here, comes across to this wire, over to that. Okay, so that would be the switch, and all of those, I can see them, they're all connected together except for two very high end ones. And if we look down in here, all of these resistors, if you can see them, all of these resistors that you see are all 22 mega ohm resistors. Wow, those are some high resistance. Okay, so I'm going to guess that there's probably nothing wrong with that big old cap. That's not one of those plastic or those paper covered things. That's a big old plastic cap. And since it's getting there at all, I believe, since it's getting there at all, there's the cap that we're talking about right there. And since we're getting any kind of reading at all, I would say offhand, yeah, that's fine. And the switch is fine. That cap right there at .02, that's our next culprit. So let's find out which one that is. That is marked. That is not marked. It's just .02. All right. Well, let's see where that is. Those are right there. So that one goes right on to pin 2. Well, first of all, we got to get this board out of here. How does this board? Oh, okay. That board's in there. It's being held down by, if you can see that, maybe. Kind of hard to see. These things weren't really meant to come apart, I guess. The board's being held in by these two nuts. They're screwed right on the back of the meter. So we got to take those nuts off first. All right. Let's get rid of this. That's cute. Somebody decided they didn't want to buy batteries. Okay, I'll go along with that as long as it's working. I guess it's 1.5 volts, so it must be working. All right. There we go. I can get into there. What size is that, I wonder? That size. Okay. Okay. There. Those guys are off. Interesting design. But remember, these were kits. People put these together. And they were not. This one wasn't a hard kit, but it's pretty. Okay, gotta take that off too. There's a screw here that goes down to a little thing, little L bracket. Okay. Better pliers. Or not. Oh. Come out of there. Thank you. Alright, much easier to put back on. Alright, so, oh, okay, that's all loose. Alright, so, we got, what holds this? Okay, I guess maybe, actually, that right there is supposed to be soldered to this little tab that sticks over there. It's not, but that kind of explains that that was screwed on the back of here that goes down to right there. So that's I mean, it goes right to there, which is the same as that, which should be soldered to right there. Okay, why not? It's ground. Okay, anyway, makes it easier because I don't have to unsolder that big metal thing. There's our two capacitors, right there, right underneath that AC wire. We are unplugged, of course. Boy, you don't have a lot of room to work in here, and that does not come off. All right, let's see. This capacitor right here, that one, goes to one end of it goes right over to pin 1. It's either 1 or 7. I can't really see. 1, 2, 3, 4, 5, 6 pin tube. So it goes right to one end of the either 1 or 6 and 7. Okay, so that inside capacitor that we're looking at goes right here onto pin 7. See it? There's one right there. That's a little bypass cap. Chances of that being bad are pretty slim. Actually, chances of all of these actually being bad are slim. And this one here goes to pin 2 and 1. Oh, wait. Let's get a closer look at that. Light. Put some light on the subject. Alright, so those two, 1, 2, 3, 4, 5, 6, 7. Two of them are tied together there. And if I look really close with the geek glasses, that is pin 7 right there. If you can see it. Right there's pin 7. And then that means that that's pin 1. So this inside capacitor that we were looking at actually goes to pin 1 and 2, because pin 1 and 2, this one and this one, are tied together. Right there. So that inside capacitor is actually that one right there. The outside capacitor is that one right there. All right, so now we can do some checking. Phew. Okay, those guys. I'm going to guess that the inside, that capacitor on the inside there, is the one that's going to have the most strain on it. So let's go for that one first. And that would be right? Right there. Solder suckers, wonderful devices. Alright, I'll tell you what, let's take the tube out because I don't want to bend it too much. Let's take one end loose of this capacitor here. Get the little magic box. This is the little magic box that does everything. And we want the 2 red leads. Well, it really doesn't matter for this. I'm not checking the ESR. This capacitor is not big enough for, not big enough to have an ESR problem. So, let's tell you, it isn't easy getting around in this thing. Okay, so we got it hooked up to one end. Let's hook it up to the other end, right there, and give her a test. It says it's a capacitor, and it says it's 0.02, 25.79 nanofarads, and a V loss, voltage loss of 1%. Okay, well that one is fine. I wouldn't have guessed that. Alright, so let's put that back in. Nothing wrong with that cap. Solder. Interesting. Whoever put this kit together didn't do a terrible bad job. Okay. So now we got to take out the other capacitor, which is right here. Whoops. Get it? Nope. There it is. Alright. You don't have to have a solder sucker, but boy, are they nice. They come in really handy. Okay. That one's loose. So let's hook up our magic box to one end of this one. You can't, because there's so many wires on this thing, you really can't get this board out of here any farther than this. This is kind of a pain. Alright, so there's that. And attach it to that one right there. And hit the magic box. Okay, that says it's a resistor of 65.63 K. Do I have? Yeah, I definitely have. One end of that is loose. See, right there. And the other end is still in the board, but that wouldn't matter. It's loose. It's not hitting ground or not. All right, so we have a capacitor masquerading as a resistor. Interesting. Okay. See, and that is a 0.02. I don't know what the actual value is. But now we got to get that thing out of there. Alright, and that's the other end of it is right there. Right there. Alright. That's a big ground. It fell out. Alright. There it is. See? Let's, just for the heck of it, let's test this thing completely out of the circuit. Right, because, you know, this is an old piece of equipment, so we're, bad parts, yep, 62.92 K resistor in a capacitor package. Okay, alright, well, I definitely say that's bad. .02. I don't know what the voltage is on it. It doesn't say. It's not going to be a tremendously high voltage. Well, I don't know. Let's see. Let's get out the old box of old parts. Box of old parts. I've had this thing around forever. What do we got in here? Okay, let's see. What's this one? It went away. Oh well, got a lot of them. That's a 472, so 4700. That isn't it. I don't even know what that is. Don't care. This one is a .047. Yeah, that's a think about it. I don't even know what that is. 2 kilovolt, 122K. Okay. Tell you what, let's find out. Let's put it on the magic box and see what it thinks it is. Magic box says it is a 1212 picofarad capacitor. Well, 122. Okay. So 122. That would be point. No, that's too small. That's like way down there. Oh wait, what's this one? Ah! Focus. What do we got? .033. Okay. Well, it's just that'll work. I don't think I got any .02s in here. What's this? At .2. Yeah. What's you? You're way too big anyway. Sprague 10.1. No. 600 volts. No. 6800. .033. .2. Sometimes you just gotta live with what you got. .2. No idea. I could measure it, I suppose. I don't trust these things as far as I could throw them. I don't even know what the value is. Now I'm going to go look it up. Okay. Alright. I'll tell you what. Let's put the .03 in. .03, it's probably 20%, so it's going to be close. Alright. Here we go. Hey, it ain't rocket science. And this is old stuff, so, you know, it's probably pretty forgiving. Let's, well, you know what? Remember I said something about old box of old parts? Let's measure this guy. Make sure he's still any good either. Okay, so magic box. Magic box says 25.89. Perfect. .02. A little higher V loss, but don't care about that in this situation. Okay. Alright. Always check first. Alright, so this is a pain to get into. There we go. Got it. I know this capacitor is newer than the one that's in here because this particular piece of equipment is from the late 50s. Yes, I said late 50s. This is a V-7, not even a V-7A. This is a V-7, so it's pretty old. Alright. Now for some soldering. There we go. And you. Good. Well, those are big traces. Okay. This is seriously old school, folks. Okay. Normally I don't cut things off right now, but since we know that that resistor is bad, or that resistor, that capacitor is bad, for sure, take off the leads of this one. Okay. Capacitor has been replaced. Did we get, yeah, the other one is in there. Okay, so there we go. Now we got to put it all back together again, and we have to make sure, there we go, that we get this up on top where it belongs, and that the, okay, and before we go any farther, let's put the tube back in. Tubes only go in one way. Can't possibly do it wrong. Well, I suppose you could if you really got crazy with it. Alright, so there we go. We got that back. Put that down. Get one of these guys. Put him on. Screw him down, make sure he's not shorting against anything. There we go. Okay. Don't want to crank on it like it's on a car, but it's got to be reasonably tight. Yeah. Sometimes working on this stuff is kind of like working on a car. It was made to be put together as a kit, not to be repaired. Okay. Oh, for crying out loud. Get on there. There we go. Alright. Go in a little bit of an angle, but that's fine. Make sure that it doesn't turn. There. Alright. Yep, those are on. Okay. Nothing shorted underneath them. Nope. That wire's loose. Those wires are loose. Put the little bodge board back. Oh, there it is. Okay. Screw goes there. And a nut. This is non-factory standard. Okay. Ta-da. The ground wire, of course. I hate flathead screws. Alright, that's all there. That's in the right spot. That's all clamped down good. Alright. That thing there is not grounded to anything, so I'm just going to leave that on when we test it. Make sure everybody's back in place. Okay. AC off. Plug it in. Got let's see. Got to be careful on these guys, because once you turn this on, there's a couple hundred volts in there. Okay. On. Yep. Light came on. That's a good sign. Oh, there goes. Up and down. Okay. So we knew everything else was right. Let's turn the function generator back on again. Get my little leads. Here we go. We know that the, ooh, that's, okay. Well, yeah, it's picking up air. Doink. We really should let this settle down, but we know that the output of the function generator is about 10 volts. So let's put this on like 15 volts. Short your leads, that's good. Ground. Wow. Ha-ha! We're a little high, but let's crank it down some, turn it back up some. Well, how do you do? I believe we fixed this thing. Let's put the multimeter on it. Beep, beep, beep. Okay. Okay, there we go. We got 9.9 volts, and this thing is reading a little over, well, it's reading 12. All right, well, then we got to do a AC balance on this because we replaced the capacitor. So in order to do the AC balance, what you do is you get rid of this, you put it on 50 volts. I know this because it said so in the manual. And you go back and forth between DC and AC. Alright, so we got, unfortunately, pretty good. There's DC plus, there's DC minus. They're off a little bit, but like I said, the tubes haven't warmed up. And there's AC. So the balance is actually correct. The idea is to get it so that you don't have to turn this knob when you change values. So the AC balance is correct. The problem is the AC itself is not. There is an adjustment back here for that. Screwdriver. Hello. I don't want that one. That's too fat to fit in there. Okay, here we go. There is, where is it? It's, whoops, get off of there. It's back here. There's your AC balance. Is right. AC balance is right there. Your other one in here is DC calibrate, which is right there. And this one over here says AC calibrate. So let's see what we got going. Well, we know we got 9 point. Yeah, it's coming loose over here. We got 9.918, close enough to 10 that on a meter it doesn't matter. Let's see, so we want to 9.9 volts. Right there. Okay, so we're going to let this sit for a minute to make sure that it's okay, and we'll be back after this thing warms up. Okay, we're back, and it's still right at 10 volts, right there on the 15 volt scale. See? Wonderful. So let's turn her down and we'll do a measurement. We'll go down to 5. There's 5 volts right there. And we'll look at our meter, the known good one, and see what it says. It says 5.08. I can live with that. That's great. All right. So we have affected and a repair on the Heathkit V-7 digital voltmeter, or non-digital voltmeter. The old VTVM. It's interesting. Some of the parts in this thing. Get a close-up look here. That right there, that is a big old diode. Yeah, big old rectifier diode. There's your tubes. If you turned all the lights out, you could see the tubes. Followed by a relatively modern LM317 voltage regulator to replace a 1.5 volt battery. Alright folks, well, there we go. We have fixed it, and it's going on the bench in service. Why not? Thanks for watching.